understand what you're saying. It's a different degree. The first and the third are odd degree functions. So yes, that would be right. You notice anything else? Anybody else have something else that they noticed? There's not a right or wrong. We're just spilling out what we notice. All right, class has already started. I'm going to give you one more minute. So put your thoughts out there, guys. Let's have a conversation. Don't let me talk to myself, okay? All right, I've got the timer on. And just go ahead and keep talking about what you notice. I need to get me a better timer. Let's see. All right, good morning. Yeah, you notice that the second option looks a little different than those others. Look at the end behavior. We've been talking about end behavior. Where does it rise and where does it fall? Understand what you're saying. It's a different degree. The first and the third are odd degree functions. So yes, that would be right. You notice anything else? Anybody else have something else that they noticed? There's not a right or wrong. We're just spilling out what we notice. All right, class has already started. I'm going to give you one more minute. So put your thoughts out there, guys. Let's have a conversation. Don't let me talk to myself, okay? All right, I've got the timer on. And just go ahead and keep talking about what you notice. I need to get me a better timer. Let's see. All right, good morning. Yeah, you notice that the second option looks a little different than those others. Look at the end behavior. We've been talking about end behavior. Where does it rise and where does it fall? What quadrants? So many of you have noticed that the second, and I'll go ahead and label these so we can talk about 1, 2, 3, 4. 1, 2, 3, and 4. There we go. The second one, it rises in the first quadrant. It rises in the second quadrant, and it kind of has a bump right here. It has a root or a solution here. All right, our timer's going off, so let me turn that off, and let's evaluate that. All right, some other people are saying the last one. All right, so there's a difference here. I'll agree with that. Okay, what degree is, this is an odd degree, and this is an odd degree. But the leading coefficient of this one is going to reverse. So the leading coefficient is also going to be negative. This one, the second one, is even. But some of you noticed in the chat that the last one isn't even a function. Okay? The best answer would be number 4. Because if we do the vertical line test, and I'm going to change this to a green color and draw a vertical line, I can find 3 points of intersection. One right here. So we would have 3 solutions, 3 y coordinates when x is whatever this point is. So this is not even a function. The other 3 are functions. Okay, so the best answer would be number 4. All right, so we're going to look deeply and use our vocabulary. All right, a challenge. The Quizlet Live Challenge. All right, you can join this game at any time. And I'm going to put this link in the chat. So you can just click on the link. And as soon as we get 5 people, we'll start, but you can join at any time. There, you got in there. Do y'all want to see how y'all are doing? Y'all want me to share my screen? It won't show up on the recording. All right, where did everybody go? All right, get back in, guys. There we go. I'm going to go ahead and start the game before I lose y'all. All right, it's going to show up on your device. All right, Kayla, it says that you're disconnected. If you want to rejoin the game, refresh your page. Okay, I'm going to wait for you to show back up again. Taylor, you're in. 3, 2. Game, refresh your page. See how you do. All right, I'm going to share my screen. All the possible x values of a function. Okay. All the possible x values of the function. That's going to be the domain. Let me approve y'all that are trying to get in. If any vertical line passes through no more than one point of the graph of a relation, then the relation is a function. We just did that a minute ago in our example. 3, 2, 1. This is a vertical line test. So if you've been reviewing your vocabulary weekly, this is going to be relatively easy. It's going to be a lot harder if you've come in late and haven't had a chance to review that vocabulary set that I make for you for each unit. All right, b squared minus 4ac is the expression under the radical sign in the quadratic. It is called what? There's a name for it. Dividend, discriminant, I don't see the other two, increasing or decreasing. That's the discriminant. All right. You've got roughly 30 seconds. All right, any set of ordered pairs, is that a range, a domain, a relative extrema, or a relation of a function? Tell me what you think. 3 seconds, 2 seconds, 1 second. All right, it is, y'all all got that right. All right, all the possible y values of a function. What are the y values called? Principal square root, relation of a function, range, or domain? All right, we're counting down just a few more seconds. 5, 4, 3, 2, 1. All right, the y values are the range. Y'all are doing great. Everybody got that. All right, this type of bracket at the end of set interval indicates that the interval is closed and that number adjacent to the bracket is part of the solution set. All right, is it round bracket, square bracket? It's going to be one of those two, relative extrema or turning points. All right, the square bracket includes that number that's next to it. So that would be shaded in on your graph. On the graph of a polynomial function, this means the graph is going up. What is the word that means going up in math? 5 seconds, guys. Dividend, decreasing, increasing, or discriminant. Going up, we use that word early on in elementary and middle school. We call it increasing. And then we, again, pay attention to the terms that mean increasing on a graph. All right, means writing the polynomials with the exponents in decreasing order. To make the calculation easier, it's expressed by writing the highest degree term first, then the next degree, and so on. Sometimes we have to fill in missing terms with zeros. That's standard form. Okay, and so when I say standard form, let's get used to knowing what that means. So that vocabulary review is important. All right, this type of bracket at the end of an interval indicates that the interval is open, meaning the number next to it is not included. So we open it up. There can be holes in our graph. What kind of bracket indicates a hole? Everybody, y'all are doing great with vocabulary, guys. Look, a round bracket. And it's not going to hurt to try, okay, because this is how we learn. Remember, a polynomial function of degree n has n complex roots, real and non-real. Some of these zeros may be repeated. We call that multiplicity. So is that factor theorem, quadratic equation? It's the fundamental theorem of algebra that states the highest degree is going to tell us how many solutions, real or unreal. All right, question 11 out of 12. A relation in which every element of the domain is paired with exactly one element of the range. Now, this is what the vertical line test eliminated that last choice for us. It's a function. All right, sorry guys, I'm trying to let this person join. All right, and one more question. Oh, I'm sorry, I bumped you out of that question. I didn't mean to. On the graph, let's look at that. Of a polynomial function, this means the graph is going down and that's decreasing. Well, let's see who's on our leaderboard here. Zaylee, Christopher, and Sophia. Give them a round of applause, guys. Y'all did very well on the average score. All right, so those of you that participated, I'm going to put your name in the drawing because you're brave. An extra time. Yay, Saeed, I'm very glad. You got every question right and you guessed half of them. So guessing is okay. That's how we learn. All right, I'm going to go ahead and stop sharing and let's put our playlist back up and let's move forward. All right, that was fun. What did y'all think about that? Do y'all want to do that kind of thing again? That's okay, Landon, because we learn by doing it. Sometimes it doesn't work, sometimes it does. But if you're paying attention, then we should learn something. All right, this week, you should have gone through the Instruct. The Instruct inside of the course is your textbook. That's where you take notes. That's where you practice. That's where you decide if you need to come in if you don't understand something. But do not skip this. Don't just look at your plan and try to get assignments taken care of. Some of those assignments count, some in the grade book, some of them don't. So this is really important that you go into every Instruct piece and that you practice taking notes, because this week, starting on the 22nd, that's this Thursday, or maybe it's even, yeah, on the 22nd, you'll be able to turn in your notes for 2 weeks for extra credit. Okay. All right. So we don't have a whole lot this week except for reviewing for the exam. So I want you really to put your focus on that. And on Thursday, again, math teachers all update grades on Thursdays. So please don't keep telling me when you've completed something. I'm proud for you, but I'm just not going to have enough time to respond with that kind of email. So what I'm going to suggest to you is on Friday morning, you look at your grades. And if I miss something, that's when you can tell me to take a second look. But I would highly recommend that you come in during office hours on Thursday at 10 o'clock or Monday to discuss grade questions. Email is not the place, and we're not going to get bogged down in that. It's a lot quicker for you just to show me if I missed something, or for me to point out maybe that your name wasn't put on it, and we correct that early on. Okay, any questions about that? All right, we're going to move into the first question. Tell me if you're ready in the chat box. Say, I'm ready. I've got my calculator out. I'm going to check your work and somebody be brave enough to get on the mic because I'm not going to be able to see the chat as soon as I do this. Are y'all ready? Very good. Thank you. Thank you. Thank you. Thank you. Don't neglect any teacher graded assignment with feedback because you can resubmit those. There's no limit to the number that you can resubmit. So look at my feedback. All right, big congratulations to our first winner of our class drawing for our Nearpod person puzzle. All right, clap, say yay, congratulate in the chat. I'm very excited about this. So everybody that took on my challenge, and there were just very few of you that did that by the date that I gave you, got your name in the drawing, and it was a $25 gift card. Okay, awesome. Y'all are awesome. All right, question number 1. How does multiplicity of a 0 determine the behavior of the graph at that 0? Now I'm going to be working through this, but I want to hear your chat in the chat box, or I want to hear you go on the mic. Where do I start? What does a 7th degree polynomial? Do I need to know the degree of the polynomial? What does that tell me? Think about it for a minute. Get your notes out. It's an odd degree polynomial. So let me write that down. In behavior. Very good. Very good, Sarah. So with an odd degree polynomial, what does that have to do about anything? We know that it's going to go up and down in opposite directions, either like this or like this. Even is going to go up in the same direction and down in the same direction. All right, anything else? We're talking about zeros. All right, let me look at what's in the chat. How to solve the question. Yes. Okay, so if you've been practicing the quizzes and the unit test, so now this is starting to all come together. All right, so what does zeros mean? Let me write this out. I have a 0 at -5. So that means it's going to cross the x-axis at -5. Let's put all this together. All right, so if I bring everything over to the left in my function, it would be x plus 5 equals 0. That would be one of my factors. And then you would have to set it equal to 0, and that's how you get your solution. Let's put it back in binomial form, okay? Does it say anything about a multiplicity there? I don't see it. It just has a comma. So that means it's to degree 1. All right? Very good. We'll cross over. You're putting a lot out there for me, and I appreciate that. Very good. You got your notes out. All right, so that's going to help me a lot. So y'all look at what's in the chat. All right, we have a 0, so that would be x minus 0. Well, when we add or subtract 0, we can just leave that off. And what is the multiplicity? It's 2, so we're going to put a 2 up here. All right, now we've got a root at 3. So I'm going to pull it back into this binomial. So would it be x plus 3 or x minus 3? I'm going to look for some kind of validation because I start going too fast and I make mistakes. All right, so that's what I thought. Thank you very much. And what degree or what multiplicity is that? That's 1. I don't need to write the 1, but I am because I'm going to go back and double check. All right, we also have a root at 4. So how would I write that? X plus 4 or x minus 4? X minus 4. And you're already writing on the board, so I appreciate that. That gives me something to go back and check on. So x minus 4 with the multiplicity of 3. So let me go ahead and write that 3 here. All right, so let me add all those up. I've got 2 plus 1 is 3, plus 1 is 4, plus 3 is 7. So let me go back and see if I got all this right. Does that add up to the original statement, a 7th degree polynomial? Yay! All right, so that helps me to double check, and I don't think I made any mistakes. So now that we have the multiplicities, the graph of the function at x on the x-axis at -5 we have a multiplicity of 1, so that crosses straight through. Okay, so we're taking our answers from here and dragging them. So that checks. Anybody have any questions about that? Y'all understand how we got that? Go back to your notes and look in the I Can for notes that help with that. If you have come in a little bit late or you're not really ready with your notes, because you can use your notes on your test. Going really quickly, answer one question. Yeah, well, don't go too fast on the test. Take your time. All right, and go back to it if you need to. Save the questions. All right, the graph of the function at x equals 0. Let's look at, that's going to be this one right here. We just dropped that 0. It has a multiplicity of 2. So it's going to bounce because remember, even that end behavior, they're going to point in the same direction, either up or down. So it hits the x-axis. It's tangent to the x-axis. That's another way to say it. And so we got that one right. So we're bringing our vocabulary up a notch. All right, what about at 3? So it's going to be this one. We have a multiplicity of 1. So again, that's just like a straight line. It just goes straight through the x-axis. All right, and then also at x equals 4. So we have a multiplicity of 3. So anything higher than 1 is going to hug or flatten out before it crosses through, but it will cross through. So you could get confused because this would be a correct answer, but this is the best correct answer. All right, any questions about that? Tell me if you're ready to move on. I'm going to go ahead and clear this page because, all right, let's go ahead and move on then. All right, what is the solution to the rational inequality? Give me some hints, guys. Where do I start? Crosses while hugging through. All right, throw some ideas out there. How would I solve it? All right, crosses while hugging. We don't know yet. This is, we're kind of changing direction. It's not an equality, it's an inequality. So let's identify what we know from the problem. Let's go back. All right, so Sarah says subtract this 2 over x minus 3 from both sides. Why not multiply through? I like that. But why not multiply through by x minus 3? Do we know if x minus 3 is positive or negative? Very good. If this expression is less than 0, we would have to change the direction of the sign. And we have no idea of knowing that. So you cannot simplify, because that would be my first temptation, is to do that to make it easier. So exactly what Sarah said, we're going to put these all on one side. So I'm going to move everything over to the left. 5x, what am I doing? I get really tired of writing with my mouse. All right, so we're going to subtract this from both sides. So we'll end up with 5x, and then we have the same denominator. So I'm skipping steps to save room on the board. I need that room. So we can combine the numerators. 5x minus 2 over, no problem, x minus 3. All right, so let's go ahead and take a look at that. I'm going to put that on a number line. Okay, so take notes here. All right, so I've got a number line down here. And remember, this is less than or equal to what? We aren't multiplying or dividing because we don't know what this expression is, okay? So all we can do is add or subtract. All right, now we have this. Let's look at important parts, okay? At x minus 3 equals 0, x would be what? Where is our point of interest? X minus 3 equals 0. Add 3 to both sides. It's not going to be negative 3. X is going to be, very good, positive 3. So on a number line, we're just looking at our x's. We're not looking at the coordinate plane. So I'm going to find 3. That's a point of interest. Now, is that a valid solution? If I put 3 in here, we get 0. Can we divide by 0? Yes, get your notebook out. No, we cannot divide. Thank you. So we're going to circle where 3 is. That's a point of interest. It's kind of a stopping place on our graph, but it's open. All right. When we look at the coordinate plane, we would have asymptotes or a hole in our graph. Now let's look at the top. 5x minus 2. If we set that equal to 0, that would be a solution because we can have 0 in the numerator. So add 2 to both sides, and you get 5x is equal to 2. A lot of algebra here. And then divide by 5, and what is x equal to? That would be a valid solution. Another point of interest would be 2/5. So somewhere in here is 2/5. Okay, do we circle it? Is it part of our solution? You need to look closely at the inequality. Does it include equal or does it exclude equal? Do we color it in or do we leave it open? It's a closed circle, yes. All right, we're going to color this in, and that's included. So now what I'm going to do is I'm going to divide this into 3 sections on the x-axis. And I'm going to call this section 1, section 2, and section 3. Now what we need to do is we need to pick a number, any number that you think is easy to work with in section 1. Can you throw out just any number in this section? We're going to test it to see if we get a true statement. Something easier than -1. Easier than -1. 0. All right, put 0 in here, and you get 5 times 0 is 0. 0 here, 0 minus 3 is -3. Should be less than or equal to 2. Let me erase those marks that I made. So we'll see the original. Over 0 minus 3. What is 0 minus 3? -3. Thank you. I want to trust myself, but if I see that y'all are using your calculator, I feel more confident. All right, this is just 0 over here. So let's rewrite that as 0. Is 0 less than -2/3? Is 0 less than a negative number? So none of these numbers that you substitute in this region are going to give you a true statement. So that's no or false, however you want to look at it. Let's move to the middle. And what's a number in region 2 that would be easy to substitute into my original inequality? 1. All right, so let x be 1. All right, so 5 times 1 is 5. And what's 1 minus 3? 1 minus 3 is almost 2. It's a -2. So if I put a 1 in here, I get 5. And then 1 minus 3 is -2. So that's -5 over 2. Is that less than or equal to, let's go ahead and substitute in x right here. We already did it once. 2 minus 3 is 2 minus 3 -2? I trusted y'all. 2 minus 3 is -1. All right, but I'm just giving y'all a hard time. It's good to have you put ideas out there, but I need to check them. All right, so this is -5 less than -2? We are using -1. So if you put -1 minus 3, no, we're using +1 right here. We're using +1. So pay close attention. -1's way over here. We've already checked that region. We're using +1. Okay. All right, but in any case, It gets confusing, so slow down. That is a true statement. All right, you don't need to, Taylor. I'm creating a help video that will be up by this afternoon if y'all don't inundate me with emails telling me to check your grades. All right, guys, don't hit the question mark because I can't see your chat. Keep it all in the same room, because that'll slow us down. Trying to scroll through your chat, but remember, I need somebody on the mic because I can't read everything in the chat. All right, so I will have a written review and I will have this entire thing because there are 14 questions. We're only going to get through a few, okay? So you'll have that video to help you. Don't rush through the unit test. All right, when we check section 3 and I pick the number 5 and plug it in, I get a false statement. So this doesn't work. So I'm just going to fast track you through this. Any number in between 2/5, including 2/5, up to 3, excluding 3, is part of the solution. So writing the solutions, yes, I will in the video. Okay, stop asking about that because, again, can y'all hear me say I can't read the chat? I'm going to stop going over there.
Yes, ma'am.
All right, thank you. Thank you. That'll help me if you get on the mic. All right, so I'm going to write this as set notation. When we shade in 2/5, we have that hard bracket. Okay, that means I'm including 2/5 and all the numbers in between 2/5 up to what number? Up to 3, but not including 3. So that's the soft bracket. All right, if it were these two, I would write the set notation with a U in between, but not a U. I've had this a couple of times. You get 3 chances on the quizzes to figure out that using a capital U and not using the keyboard tools, the mathematical set tools, is going to get counted wrong. Okay, so make sure you're using the set notation for union, not the capital U on your keyboard. Just some things that I'm pointing out that will help you, but don't move through this too quickly. All right, let's move on to the next one. Now this one, I'm going to take some time because this is the biggest question. If you did not go through the course content and practice, this is going to be a little bit of a challenge. Do y'all want me to just work through this quickly to give you an example?
Yes, ma'am.
Or do y'all want to participate? Do y'all want to see it or do you want to participate? Hey, Taylor, do me a favor and get on the mic if I miss anything. You check the chat
Yes,
for me,
ma'am.
okay? All right,
Okay.
Thank you so much. All right, so what's going to happen is I'm going to break this apart into 2 fractions. So what I'm saying is if I had a fraction 5/6, I could break it into, maybe that 6 could be halves plus thirds. And maybe I could have 1/2 plus 2/3. What would that be? What's the common denominator? Let's just go back to basic fractions. Okay, I would have to multiply by 3/3, and I would get 3/6. And then I'd multiply by 2/2. Is that right? And then I would get 4/6, and then add that together and get something like this, 7/6. So if I had 7/6, I could break it apart into these 2 fractions. So we're going to be doing that, but here's the part that you don't like. It's not just numbers, it's polynomials. We can follow the same steps. First thing I'm going to ask you is, can we factor the numerator? Yes or no? And Taylor, you tell me what the answer is.
I want to say yes.
Okay, what does the chat say?
One person said no.
All right, what are these two? If you're saying yes, let's check that out, okay? What do these 2 terms have in common? What can we factor out? Because it's not a squared term. Okay, there's nothing, it's not a polynomial I can easily factor. I'm going to go ahead and go with no. Okay. Y'all are funny.
It took me a second.
I know. I mean, we've got to warm our brains up and we've got to check and double check. All right, use your factoring calculators that I gave you. or use your brain. I've got a tiny brain, doesn't hold much. But I can factor -10 into two factors that add to -3. Tell me what that is. I can factor the bottom. That's a yes. Tell me how to factor that. What are the two factors of -10 that add to -3? Think about it, guys. Ooh,
+2 and -5.
all right, let me put that on my T-chart. If I add those together, I'm just double checking. Yes. All right, so x minus 5 and x plus 2. So we have this factored. So what I'm going to say, and I'm going to run through this kind of quickly, is I'm going to have something, some kind of expression, possibly. So that's why I use a capital A, because it's not a simple number. All right, so A, it could be, or it could be an expression. We're dealing with polynomials. A over x plus 2 plus the other factor is x plus 5. So that would be a different expression. If we add those two things together, we should get 3x plus 2. That original, I need a pen that writes on my computer. That's we get that original expression. All right, so that would be 3x plus 2 over x squared. And I'm going to go ahead and factor this out so you can see it easily. X plus 2 times x plus 5. Are y'all okay with that? I just made up two variables, but we don't know what they are. All right, so let's take those roots, x plus 2, set that equal to 0, and where would that root or that point of interest be? At what? X equals what?
Someone said -2.
Very good. Now take the other one, x plus 5. Where's the second point of interest? -5. Thank you.
Yeah.
All right, very good. I happened to glance over there and see it. All right, so I'm going to start with 1. I'll just start with a -2, and I'll plug that in everywhere there's an x, and I'll simplify. So I put a -2 here, a -2 here, a -2 here, and a -2 here. That's not going to work because we get 0. We can't have division by 0. So let me back up. Before I start, do you remember that number, that example that I showed you with 6? We found a common denominator, remember? So what is our common denominator here? Isn't it this right here? Our common denominator is our factored polynomial. Okay, so let's multiply everything through by x plus 2. My brain forgets things. All right, x plus 2 times x plus 5. That's x plus 2, in case y'all didn't know. Are y'all laughing at me in the chat? That's okay. All right, we're going to multiply every term. So if I start with that first term and we multiply through this, that x plus 2 is going to factor out. That's what I want to happen. So we don't have to deal with division by 0. So we're left with x plus 5 times a. All right, let's go ahead and move over to the second term. This is legal as long as we're multiplying every term in this equation. So this time the x plus 5 is going to factor out. And what are we left with? Taylor, are they talking in the chat box?
One said +2.
Almost, x plus 2. You probably couldn't read my handwriting up there. It's all jumbled together. All right, so now this side's going to be easy because that's all of this. So that's all going to cancel out. So that's equal to 3x plus 2. So now we can go to the step of plugging in. Let me get a different color here. Plugging in that -2. So what's -2 plus 5? Negative 2 plus 5 is what? Thank you, Sophia. Positive 3. So we're left with positive 3a. Plus, what's negative 2 plus 2? What's 0 times b? That's right, it's 0. So we can just not write that. So I'm going to go ahead and erase that plus. We're adding in 0. Oh, it's starting to look a lot nicer. Is equal to 3x plus 2. So the goal is to solve for x. All right, so we're going to subtract 2 from both sides. So we have 3a minus 2 equals 3x. Hold on. Yeah, that's right. No. Let me back up. We're not solving for x. What are we solving for? I'm misleading y'all. Did y'all catch that, anybody? We're solving for a. All right, and we should be replacing x with what? Remember what we started with up here? Everywhere there's an x, we put a negative 2. So I forgot to put the negative 2 right here. What's negative 2 times 3?
Negative 6.
And then negative 6 plus 2 is what?
Negative 4.
All right, so this whole expression, I forgot to put that negative 2. So 3a is equal to negative 4. Divide both sides by 3, and what is a equal to? Negative 4/3. All right, so this would be negative 4/3 goes in here with the a. I'm just going to write it like this, times, that's what a is, 1 over x plus 2. We multiply that out and we would get negative 4 times 3 times x plus 2 would be the first term. Now I'm going to rush through this, and if you're not getting it, I just want you to see that first part. Everything's going to be included in the video. So we're going to do the same thing for negative 5. And just quickly, when we put negative 5 in here, not here, in here, the simplified one, this is going to go away, and we'll have b. And then we'll have negative 5 plus 2 is negative 3. And then we put negative 5 here times 3 is negative 15. What's negative 15 plus 2? 15.
Negative 13.
Negative 13. Divide both sides by negative 3, and you'll get b equals positive 13 over 3. And we would do the same thing. We would put 13 over 3. That would be our b. And then 13 over 3 times x plus 2. So that would be deconstructing that fraction.
I thought it would be 3 times x minus 5.
Let me see. Did I miss something?
We already did the x plus 2.
Okay, you're right. All right, wait for the video, and it will have all of those things because we're down to 2 minutes. All right, another one is upper bound, and this is really hitting hard the people that just started a week ago. So do not panic. You'll be able to use this video for help. This we call that the P, the constant term. This is our Q. Okay, and I only look at, we look at the positives and negatives, we do, but for speed, I'm just going to look at what are the factors of 3. I'll put the positive and negatives back in. Only has 2 factors, 1 and 3, positive or negative to get that negative 3. And then 2 only has 2 factors, 1 and 2. So all of the possible solutions are positive and negative. Whatever the P's are 1, paired up with all of the factors of the Q's. So 1 over 1, 1 over 2, and then positive or negative 3 over 1, and 3 over 2. Thank you. Very, very good. All right, then we simplify that, and then I start with my whole number, and I do synthetic division, And I'm just going to rush through this quickly because it's already 9:45. And as soon as I do synthetic division, when all of these numbers are positive, and I only do whole numbers, so I start with 1, take all these terms, divide in, and when all these bottom numbers are positive, that's my upper bound. And I just keep going up in increments of 1. I don't want you to be scared. I know, it's confusing. Didn't have enough time. We just ran out of class time. All right, so I usually have all of this is going to be given to you, and I'll send you an email just so that you don't forget with the link to this. All right, here's our exit ticket. Go ahead and complete the exit ticket. This will put you in the drawing and let me know that you are here and that you're participating and that you're brave, because that's a lot to cover in 45 minutes. But I really like that y'all are in this with me. Elijah, I can't either. It's just hard and my fingers start hurting. So do not panic. Do not rush ahead and do this. I've already had probably 50 people complete the test the first time. If you don't join us and use the resources that I'm setting in the course for you, if you rush ahead, you're going to miss out on some important things. So just spend today and tomorrow getting ready, waiting to hear from me when this video is done, so that you can stop it and start it and see the examples as you work through the test, and you will not get overwhelmed. Okay, I promise. Any questions? Okay, completing the exit ticket. You don't have to do it now, but get that information, get it set up, and that will get you in the drawing one more time, and we will have our whole group drawing next week. And you must be in class to win, unless you're in a special program like in the Flex program or special circumstances. You will not be able to get that $25 gift card. Thank you, Zaylee. All right, y'all are free to go and wait to hear from me before you, with that link to the help video, before you start on your unit test, because you only get 2 attempts. Unit test is going to count, it's going to weigh heavily. So you want to do your very best and use all of the tools available to you. All right, guys, y'all have a good week, and I will send it to you in an email. Yes, I will, because I think that's the quickest way for you to find it. So make sure you're reading your emails from me, okay? You look for pre-cal, you search for pre-cal, or you search for Rodriguez. All right, thank you so much, guys. Thank you for your help. And good luck on your test.